Today I'm going to show how I migrated my photo edit app from NanoBanana to Gemini 3 Pro image model that is also known as NanoBananaPro. So in this app, I will show a few things. The first thing is the thinking process. It's because Gemini 3 enables thinking by default, so I can include the thought processes in a response and display it in the UI. The second thing is the token usage. I display the number of token used, which is the sum of the input tokens, output tokens, and thought tokens. Thirdly, I constructed inline citations, web search queries, and Google search suggestion, so that people can find out the sources that produce the data on the image. During the migration, I also use more Firebase services such as Remote Config that load the value dynamically when the application is first loaded. So I use the Remote Config to store model informations, and they are retrieved and assigned to the Remote Config's dictionary during load time. I also use a Firebase Cloud function to configure the environment. So I make an HTTP request to Firebase so that it can read some environment variables from the .env file to construct the Firebase config and the reCAPTCHA site key. Finally, I use the Firebase Emulator Suite to test my cloud function locally before I deploy it to Cloud Run. So I'm going to demonstrate the application first and then have a detailed code walkthrough next. So let's start. So I want to demonstrate the image creation flow. So let's use the prompt to generate the current weather of Beijing. Hong Kong is very warm, and I came back from Taipei, and the weather was gorgeous. I know Beijing is cold, but I have no idea how cold it is, and I'm anxious to travel there next month, and I have no idea what to pack. Okay, so it is very cold, depending where the people are from. So for me, -3 to -1 is cold. This is my definition of North Pole, and it has a little rain. So the Great Wall of China, the Forbidden City, and the iconic landmarks are covered by snow. The search queries are current weather and dates in Beijing, and Beijing iconic landmarks. These are the Google search suggestions. So let me open one of the suggestions. Okay. So Beijing iconic landmarks. Okay, Tiananmen Square, the Forbidden City, and the Great Wall of China. Perfect. And in older model, we are used to input tokens and output tokens. Thought tokens is new to me. So the total tokens is the sum of the input, output, and thought tokens. And I can also see the thought process of the model. So planning a Beijing graphic, structuring the isometric view, considering Beijing's weather, mapping Beijing scene, modeling the scene, assessing the elements. So this is the first use case that I want to show. It is working after the upgrade. And the next flow that I want to show is conversational editing. So I use the create mode to recreate the image of Beijing. And then I want to start a conversation and edit the image with natural language. Okay. So I want to add the English city name next to the native one, and the names are separated by a /. Okay, this is the Chinese name, this is the English name, and they are separated by a /. And I want to add more snowflakes to the image. Yeah, now the image is less sunny and more snowy. So the multi-turn chat continues to work after upgrading the image model from NanoBanana to Gemini 3 Pro image. So the last use case that I want to show is photo restoration. So the black and white image is restored to a color image, and the quality is stunning. And I want to show this use case because this prompt doesn't need to use the Google search tool to look for external information. Therefore, this UI doesn't display inline citations, web search queries, and Google search suggestion. However, it displays the thought process, defining the task scope, pinpointing the key elements, considering image fidelity, verifying prompt compliance. And the total tokens is the sum of input, output, and thought tokens. So I have successfully demonstrated that image creation, conversational editing, and photo restoration use cases continue to work after this photo edit app was upgraded to use a Gemini 3 Pro image model. Next, I want to show the code where I use remote config to load model information, the Firebase Cloud function to construct Firebase config, and reCAPTCHA site key, and Emulator Suite to test the function locally. I want to do a quick overview of the Firebase surface that I use in my photo edit application. So this is the remote config of Firebase, and I have these parameters, and these are my values. So I use Gemini 3 Pro image preview model to generate image, and include thoughts is true. The thinking budget is 512 token, and the vertex AI location is global. And I can click the dot to open a context menu and choose download default values to download the default values of the remote config. And I can also download the current configuration value using the download current config file menu. And yeah, so this is Google Cloud Run, and I deployed a get Firebase config function to Asia East 1 region, and this function is responsible for constructing the Firebase config and read the reCAPTCHA site key from the .env file. This is the Firebase Emulator Suite. It's running on localhost 4000, and I'm using functions emulator only. It is running on port number 5001. So go to log page. This is the cloud functions that is running locally. So I can copy and paste this URL on a separate tab to verify the result. But this function returns a JSON object. Inside the JSON object, I have two properties. App is another JSON object that define the Firebase configuration. It has app key, app ID, project ID, storage bucket, messaging sender ID, and auth domain. And reCAPTCHA site key is, the site key for app check, and it is defined in my environment file. So during testing, the values are retrieved from .env.local. So let me see. Yep. So I define the dummy values in this environment file for testing. That's why the JSON object shows Firebase API key, send ID, app ID, and site key instead of the actual values. I mean, if I display the actual values in here, then the sensitive information is compromised, and it is a huge security risk. So I display dummy values in here instead. So I have introduced all the Firebase services that I have adopted. Next, I want to show the Angular code in my photo edit app project. The biggest change during this upgrade is to use the provide app initializer function to initialize the Firebase app, the remote config, and the app check. So let's look at the bootstrap Firebase function. In here, I have a config service that stores the remote config object, the Firebase app. I need to use them in provide Firebase function in order to construct the Gemini 3 Pro image model that the Firebase service needs to generate images. So this is a very simple service for storing two references. and I have a function to load the Firebase config. This function makes an HTTP request to the get Firebase config function to construct the Firebase config object and return it. So the object has app and reCAPTCHA site key. So I use the app object to initialize the Firebase app, and I pass the Firebase app to fetch remote config function to set up the default values and load the dynamic values when the application is first loaded. So create a remote config instance, set the minimum fetch interval. The remote config default is a JSON file with the default values. So these are the default values. The image model, the thinking budget, stuff like that. Okay, this should be 512. 512 is the minimum budget of the model, right? This is a simple application, so I want to use the smallest thinking budget to tackle the task. So fetch and activate makes a call to the remote config in Firebase to get the latest values and return the remote config object. Next, I call initialize app check. I pass the reCAPTCHA site key to the provider. Finally, I store the Firebase app and the remote config to the references in the config service. I want to explain why I use a Firebase Cloud function to configure my environment. It's because I can move the .env, the .env.example, and the CLI.js files from my Angular app to the function folder. So the .env and the .env.example file are here. And I copy the logic of CLI.js to the index.ts file. So in here, I use process.load env file to load the values from the .env file, perform some validation to get an object back. And then in here, I construct the Firebase config object with API key, app ID, project ID, storage bucket, messaging sender ID, and auth domain. And the final object is the Firebase config and the reCAPTCHA site key. So my Angular app doesn't have a server-side code. In a package .json, I remove the script that runs the CLI.js to generate a Firebase.json file inside my app folder. So in my app folder, that Firebase config.json file is gone. And in my git ignore, I also remove that line. So this is why I choose to use Firebase, use the Firebase cloud function to configure my environment. I don't need to remind myself to run the script to update the Firebase config.json file and use the properties there to construct a Firebase config to initialize a Firebase application and to initialize app check. So the provideFirebase is also modified. The NanoBanana model is a custom injection token to inject the Gemini 3 Pro image model. So in the factory function, I inject the config service. And if config service.remoteConfig is undefined, I throw an error message. If config service.FirebaseApp is undefined, I throw a different error message. And then I call the getGenerative helper function to return the generative AI model. This helper function accepts both the Firebase app and the remote config. So this helper function calls the getValue function to obtain the Gemini image model name, the vertex AI location, the include thoughts, and the thinking budget property values from the remote configuration. Next, I construct a model params object. So model is the model name. The generation config specify the response modalities array. So I need both text and image to be generated. So it's because I need the response modality.text in order to generate the thought summary, and the response modality.image is needed to generate images. So candidate count is 1. Thinking config include thoughts is true. The thinking budget is 512 tokens. In the tools array, I enable Google search by passing in the Google search object. Next, the get AI uses the Firebase app and the Vertex AI backend to create an AI object. Next, I use the get generative model to create an generative AI model based on the AI object and the model params object. The Firebase service stays the same, so the generate image method uses the prompt and the images and pass the parts to the Gemini 3 model to generate the image with the mean type, the data URL, and the base64 encoded string. So this is the code walkthrough of the photo edit app. It still does the same thing, but it has the capability of generating infographics and more aspect ratios and 1K, 2K, and 4K images. So the image quality is stunning in my opinion. So I hope you can go take a good look at Gemini 3 Pro image model and generate stunning images using the prompt, like existing images, thinking process, and the Google search tool. So have a good evening and see you later. Bye.